So, hi everyone. I'm Juhyun Choi, working for Samsung, and I spent most of my years making web platform better. And it's my honor to introduce WebAssembly to you all. And here is Bujalski, my colleague. He has dedicated to WebAssembly on our web engine. And I acknowledge him that he did a great job in implementing on page features as well as performance enhancement. Okay, agendas of today are shown in this slide. I will take first 4 sections, and Adam will take demos, and we will get together with Q&A. Hope they will excite you. Okay, we start from history of plugins. On Samsung Tizen TV platform, application can be developed using 2 technologies. One is web application, which is based on HTML5 standard. The other one is .NET framework application, yes, C#. In this session, I'm dealing with only web application as I represent web platform. And Tizen web app runs on Chromium-based web runtime. We provide versatile API set based on not only HTML5 standard, but also Tizen-specific DRM, such as DRM solution. Yes, nowadays, web is most successful ecosystem in the universe. I think no one objects to this statement, right? On a recent survey of most famous developer site, JavaScript was ranked on the top most popular technology list. You know, the second is HTML5 and CSS. And web is appealing to business and developer side. And since it lives on most of IT devices. So, yes, even if in low computing power there, web is there. So tiny app can be alive everywhere. This is the biggest benefit of web environment. So you can have countless users without big effort. Okay, thanks to the optimization technique in modern browser, yes, such as V8 JavaScript engine and some WCC committee or standard. So we can implement whatever feature we want without some obstacles, I think. However, you know the customer. The customer always thirsty for something cool or cooler, right? Assuming that we provide an airplane which can go the other side of the planet in a half a day. But client may call you in some other days. Why don't you have a spaceship, even if much faster than airplane? Yes, even if the app is running on the web browser, they don't care, as it's none of their business. So they just want to performance and functionality as native class. So before talking about main topics, could you just take a look at her? And what happened to her? Yes, some people may recognize what I can say. Anyway, I think who wouldn't be embraced as like her if we see that kind of pop-ups? We know this is ActiveX. There have many attempts to fill in the gap between native and web. But can we say were we really happy with them? All of us have experience waiting for browsers to complete something on some pop-ups and some background application, trying to install some binary which we don't have any idea. So we have no idea this kind of plugin, how it operated on our system. This leaves maybe big security hole on our system. I think I'm not the only one who suffered from it. As we reviewed, there are requirements on native class performance and functionality without security concern. To address them, there are two popular contenders. One is ASNAP.js, as I show you this slide. It is powered by Mozilla Foundation and shipped on Firefox. ASNAP.js employed many optimization techniques, such as conversion dynamic types to fixed type. The result is quite good. See that graph? It is much faster than JavaScript. So I think you may see the Doom 3 play demo on the web. Yeah, but debugging was very hard as there was lack of source mapping. And performance is totally dependent on implement and optimization in each browsers. Due to that, people hesitated to choose Agent.js. However, let's be thankful to Agent.js as your great pioneer for native web. At the same time, Google found a way, as they always have. Google presented a secure and performance-oriented solution named Native Client, aka Knuckle. Knuckle is a Google's sandbox technology which enables native code for the web. So thanks to the sandbox, native code like C, C++ code can be executed in your browsers. Knuckle also provides versatile API set like video decoder and networking API like socket and some subset of projects including thread. So the performance is quite good. So we were convinced that Knuckle offered a great solution to reuse of existing C, C++ application. Yes, these were reasons why Samsung Tizen TV chose a native client for native web. Unfortunately, native client hadn't won our glory as much as we expected. It's been deprecated by Google itself. Can you guess the reason why Knuckle ended up so sadly? It's limited to only Chromium, and no major browsers didn't support native client at all, such as Firefox, Safari, Chrome. Chrome only support, yeah, my mistake. And plus, recently, an alliance has been formed under WCC to make a new standard. Therefore, most of native client and Agent.js developers started to work on new standard. The allies always win. We knew that from the history class, right? So to concentrate on implementing new standard, unfortunately, we decided to stop supporting native client from 2022 product. Yes, it's time for diving into WebAssembly. WebAssembly is an open standard binary format to run native code in the web. The concept is very similar as native client, but in contrast to native client, WebAssembly is shipped on major browsers, such as Firefox, Chromium, and Safari, even Edge. So if you have those kind of major browsers, you can run whatever WebAssembly binary and load and run without problem. So this is very impressive for me as a web platform developer. Yes, it is statically typed and compact particle format, and it shows much better performance than JavaScript for the same operation. So I will show you some figure after a few slides. And to say in short, WebAssembly brings the safety of web and native performance together. And you know, JavaScript engines such as V8 loads and run them officially. So it means that provide the same security level as other JavaScript. Plus, thanks to Emscripten, which is a toolchain for WebAssembly, C, C++, Rust, Go, and such language can be compiled into WebAssembly. Let's see what we can do with WebAssembly. If you have some computationally heavy procedure, which is frequently called, please let WebAssembly do it. Yes, all the effort that you have to put is just develop C, C++ module, and Emscripten would optimize your module during compilation. If you want to make an image editor or video editing program for the web, please consider WebAssembly. In the similar way, you can have high-quality music apps which deal with PCM manipulation or applying filters as well as streaming. You can develop desktop-ready application for the web. While doing so, you could make use of popular and powerful C++ framework like SDL, Qt, FFmpeg, and so on. So you don't have to implement some functionality of native or performance things. You can use them freely. This is because the community of WebAssembly. The community is sharply grown up, so you will have tons of features in soon time. And if SDL and well-known game engine APIs sound familiar to you, you could continue to use them in your application. You no need to run WebGL for porting your game application for the web. And if you have C++ application already, please port it to Tizen web app. We will support you if you have any problem. And I'm sure you don't have to be sacrificed like some considerable issues. OK, this is for those who are concerned about performance on Tizen TV. You know, TV is kind of big-sized embedded, so we nearly care about performance. So we conducted tests on our latest TV, 2019. And the first one is GR Mark II score. So WebAssembly is a little lower score than native. I think 5% maybe. Even if this score does not guarantee of practical performance, but the figure seems quite impressive for me. And second and third one is AES encryption, decryption, and live Fibonacci numbers. So this can show how much WebAssembly is efficient in heavy computation. So the center, there is a WebAssembly is, I think it's about 4x faster than JavaScript for the same operation. So the result is quite clear. And why don't we move costly function into WebAssembly? OK, we have been talking about Emscripten all this time. So even if there are a lot of articles on their website, but I just quickly describe it better understanding in this session. Emscripten is kind of tool chain, like GCC. It takes a C, C++ function as input and emits WebAssembly file as or needed JavaScript file, or HTML if you need it. And those targets can be executed on browser and JavaScript engine, including Node.js. So this is a typical command to make WebAssembly file. And all configuration is written in .emscript file. So by referencing that file, EMSK manages the setting. The first one, yes, the source file, sdl2grshade.c. And most of compilation flag requires -s in advance. The second compilation option is user_sdl =2. It means it informs Emscripten to use SDL version 2 library. And then Emscripten would download its own Emscript portal of SDL version 2 automatically and push them into compilation unit. And the other option, legacy GL emulation, is kind of version matching between OpenGL and WebGL. And the last function, last flag is DCO. You can assign the target. And for this case, this is for the beginner. You can have entire package, which is HTML5 application. So by loading them, you can ensure the WebAssembly module is working well. But if you have your own existing web application and just loading special functionality of native, you can give it JS. And by loading that JS, you could import the functionality of native by your hand. OK, here is an example to demonstrate how easy it exports C or C+ function to JavaScript. So mbind is a kind of utility in Emscripten. On C there, love function is native function. I want it to be called into JavaScript code. And what I did is just adding into block of Emscripten_bindings. And then during compilation time, it will pass and make some glue code to use with JavaScript code. And see that in JavaScript module love, this is kind of similar convention as native. Or there are more utility to use with native function to JavaScript. Please find these articles on their website. OK, as I mentioned, we will stop supporting native client to focus on WebAssembly. So I will describe some migration plan here. As WebAssembly matures and native clients is deprecated. This slide shows our plan. So I'm so happy to tell you that we can support WebAssembly from coming product to 2020. Of course, Knuckle is still alive, and it lasts until 2021 product. But however, from 2022, there's only one survivor, WebAssembly. We don't support native client anymore. Well, we expect the owners of Knuckle apps have full 2 years for migration. And if you have a further question of this deprecation plan, please contact me. Anyway, this deprecation plan may scare of Knuckle app owners, but thanks to Pepper.js, Knuckle apps can run on other browsers as well as Chrome. Pepper.js is a kind of polyfill that enables Knuckle to be compiled with Emscripten. But of course, it has some drawbacks, so performance issue and feature gaps, because Pepper.js is based on web API implementation. Please be aware of it during compilation, migration, and if you have any issue during that migration period, please contact us. We will be glad to assist you. OK, next I'm going to introduce Samsung WebAssembly APIs, which gives you native functionality with high performance. If you have ever tried to port your C, C++ application, then use socket APIs with Emscripten, you would have come across many issues. Because socket of Emscripten is totally backed by WebSocket implementation. And it does not support fully POSIX or VSSocket at all. So it's very hard to use socket APIs in your native code. To address this issue, we implemented socket features on our browser and added glue layers to use with Emscripten. The final result of this effort were really fully functional and high-performance socket APIs usable with Emscripten. You no need to modify your own code at all. So evidence is there. The performance is quite enough. If you see our demo program, which is a game streaming client app, we don't have any performance issue even 4K streaming at the same time. Plus, we provide an Emscripten port of NIP core, which is widely used for networking in native world. OK, here is our media API called WebAssembly player, Wasm player. Wasm player is a unified C++ player, which is hardware accelerated. And it accepts two kinds of media source. One is URL, as you see there. And the other one is element stream packet. And for example, NAR stream for HEVC codec. And for URL case, it's very easy to use. And I will cover it with sample code on next slide. And for element stream case, you are required to use your own, implement your own demuxer and stream downloader. If you have already your own video stream solution for native, it fits you. And we support famous DRM, ready for Microsoft, and Widevine from Google. And your encrypted data will be decrypted on our secure zone, and which is called trust zone. And regarding subtype features, we will support some external file-based subtype feature as SMI, SRT. The firmware will process them and triggers callback on time with proper string. And you can render them with your own way. And in a similar way, we will support CA 608, 7A spec, but different things is you can have a whole VBA structured data. And the last main feature is low latency mode for video rendering. It reduces the delay between package presentation to the player and rendering them. The best candidates are game streaming app and video conference call. So the demo at our kiosk shows up this feature, and please visit us and see that. You may like it. And this is a simple player sample, and which is working on. And it is hardware accelerated and supports almost core codec as native player. You could inherit that HTML video element listener, and you could get proper information by overriding those virtual functions. But it's quite simple. And the main object is media element from the bottom. So please set it the listener on there. And you can control them with that API, media element play. But please aware, you need to link it with video tag. So if without that class ID, video tag, we don't find your native code on our web app. And it's quite straightforward. So less than 39, you can have native player on Tizen web app. And lack of time does not allow me to demonstrate some other advanced project which require you to have demuxer and Steam downloader. But reference code will be updated on our website. OK, this is the result of that web. We are planning to provide low-level video decoder APIs. You may like this feature if you want or are developing a video editing program and want to demonstrate how videos look by apply multiple filters at the same time, or simply you can have a player which can play multiple video clips at the same time. You can push the video frame and get the decoded frame, decoded data, right? And you can process this data if you wish to and rendering them in your graphic frame without any restriction. And these APIs not only use hardware decoder, but also software decoder if needed. Purely, it's based on the number of videos on your application. And of course, it's limited by platform and model capability by factors such as max bitrate and max resolution, so on. I think you can build your own custom player with this API. Here are very useful and well-known C++ libraries here. You may like it, I think. In terms of Emscripten, some of them are ready for use right now, but others are under our to-do list. You can check it whether it is available or not on our website. Okay, in this slide, I'm giving you some practical advice about developing a Tizen web app featured WebAssembly. WebAssembly leaves privileges to use privileged features such as file access and using networking and utilize audio and video devices. So for example, if your code uses socket API, please add internet privilege into your manifest file, which is called config.xml. And please notice that your wasm file size matter on the storage as well as its startup time. The size of wasm file larger, it may increase your startup time. So this is a common concern on ARM-based devices. We don't have yet liftoff, which is a base compiler, shipped on cutting-edge browser, but we don't have it yet for ARM. So even if the efforts are made to reduce the time for startup time, you are required to optimize the file size. There are a lot of guidelines on the net. Of course, we will upload the Tizen-specific guide for reducing that web size. And please think your app is totally running on big-sized embedded device. So you know, Samsung TV composed of very wide lineup from low and high end. So your effort of optimization will shine on millions of low-end products. So meanwhile, here is our effort to speed up startup time. WebAssembly module could take considerable time to compile. Instead of compile every time, we compress and cache them, which is compiled by JavaScript engine from the first load. So this highly improves startup time from the second load, like as a rate of speed. Yes, we have a developer site for you, and we provide useful materials from first quarter to 2020. We will give you many tutorials and demo apps, including sample code. And mainly, you have to download Emscripten official toolchain with our libraries. It will open you to use native functionality for Tizen platform, like hardware accelerated player and decoder, something on. Yes, this is my last slide. Thank you for your attention. Adam will take over from now. Thank you.
Thank you, Juhyun. I will tell you about our demos, and the first one will be Tizen Studio. Okay, Tizen Studio is our basic IDE for developers. In this Tizen Studio, you can develop application, pack application into a widget, and deploy it on the TV. render, debug it there. So our job was to extend this IDE with ability to add WebAssembly modules there and debug them on the TV. Here I will show you the brief outline how to add WebAssembly module to Tizen Studio. If you have a project which has enabled support for WebAssembly, you have a menu for adding new WebAssembly module. When you choose it, you have a dialog which you can use to select some template. And after that, you will have a nested project which contains the WebAssembly module. That module can be compiled using Emscripten toolchain, and later the whole project will be bundled as a widget. If you will have a larger project and you will use your own build system, you can use Tizen CLI interface to pack WebAssembly module into the widget and run it on the TV. That's all in terms of Tizen Studio. Now to come to second demo, which is game streaming. Basically, we use our APIs, which was described by Juhyun earlier on this show, and we provide a game streaming client on the TV. What we did is basically we took open source project, which is Moonlight, which is called Moonlight, and this is a client for NVIDIA GeForce Experience streaming. We modified the source code so we could run it as a WebAssembly on the TV. And this project is about game streaming. So the client is on the TV. It gets input from the gamepads or other stuff, send it to the PC. PC do the whole game rendering, the logic. Then it encodes the audio and video and sends by using RTP, RTSP protocol to the TV, which displays the video and displays the audio. Here is a screenshot for the demo. In our lab, we are able to have 4K game streaming using 18 megabit bandwidth. However, we'll need the high-end GeForce RTX 2070 to do this. You can see it ourselves at our kiosks, check the latency of the whole solution to see that you can play the game smoothly. So come on, see it live to our kiosk. That's all, thank you. There was one, if somebody have a questions, please use the microphone on the right side of the class. Thank you.
Hey, thanks for this. That's very promising. Specifically on WASM, so maybe you said this, but just to confirm. So you're saying that the output app of that is going to have better memory utilization and file size? Because I know that some of the challenges that we have on web apps is lack of memory for like video playback and those kind of things. So how optimized is going to be the output of that?
How optimized memory for?
Yeah.
You mean memory usage or for a compilation?
The output app, basically, when you want to run that on the TV, is that going to use more memory? Is it going to use less memory than, let's say, the native app or, let's say, another web app? What's the memory utilization?
We haven't measured compared to the web app, but basically our web engine, which runs is Chromium, running on ARM microprocessors. So you can expect that if you have comparing the Chromium to our web app, the memory usage will be similar. Our game streaming solution uses, as for WebAssembly, around 130 megabytes of memory, just for my WebAssembly. Our limit is, as far as I remember, around half a gigabyte for a whole application.
Okay, yeah, thanks.
For NACL applications, you currently need a dev firmware TV, like a TV with special dev firmware to debug the application, like the C++ application. Will that be the same for WebAssembly? Will you need special dev firmware, or will you be able to just use a TV by like whatever Best Buy and like debug the C++ code with WebAssembly?
So are you asking about the way of debugging the code of WebAssembly, right?
Yeah, like if you want to debug like a native application.
Yes. So sometimes we struggled with the debugging function, but okay, to be honest, from next coming product, we don't have that source level debugging. We don't support. But for the next, we are expecting the next year product, there is feature for source mapping debugging, source level debugging. So you will have the feature on other product. Or if it is simple and we could migrate it to previous product, but we have just plan. I cannot say some severe, fixed schedule at this time. But you can mail me. I will let you know what will happen there.
So like 2020 TVs and 2021 TVs won't have.
2020 TV does not support source level, source level debugging, but 2021, 2021 can be supported.
Okay, thank you.
Yep.
Yeah, so my question is, I understand some of the functionality in, if I use develop an application, I would have to use your SDK in my C application, for example, right, to use some of the hardware decoding or networking functionality, which then makes the thing kind of depending on your Tizen platform, isn't it? So that makes it incompatible with other platforms or with other kind of PC browsers, is that right? Or how do you see that being one development for all web application browsers?
Actually, these APIs are specific to our TV. Right. For example, regarding networking, it's less specific to our TV. However, the browser vendors have some security concerns regarding providing their APIs to all the browsers. So we would like to, for example, propose such API to be used around all the browsers. However, the browser vendors are in different situations than we, as a TV providing platform for the TV. The browser vendors usually runs the applications from the internet for an insecure source. Here we provide for example, in case of sockets, provide this API only for web applications, not the web pages on the TV.
Okay.
So there's a different trust level between the web browser on the PC and the web application on the TV. That's why this API will be Tizen-specific for Samsung Tizen TV. The same with the video decoding or video playback. On the PC, you can decode the video on the CPU. No problem with that. The CPU is quite powerful, even on lower PC. However, TV, you aren't capable of decoding the video and doing something else in the applications. That's why we have special DSP for that. And to allow it to use it, it has to be Tizen-specific. That's why this API rather won't be wider than our Tizen TV platform.
Okay, understand.
Okay, if you guys doesn't have any other question, can you close the session? Okay, thank you for your attention. Thank you.